you said that you create one dummy question.
We're talking about chain rule today, but our real focus is the test on Friday, right? So if this starts interfering with brain space, you'll wait till after the test. Now, I do have a homework 4 set up for you, but it's very easy. One problem with the product rule, one problem with the quotient rule, and one tangent line, I think, with the quotient rule. So, so you certainly can do that before the test. You can do it Saturday or Sunday. I think in the announcement I have it due on Tuesday, but I still want it Monday. Okay. 3 problems, very simple. In fact, I think I did 2 of them in the lecture. So just want to make sure that you're ready for this product rule, quotient rule piece, because it's going to be inside the chain rule. Now, do we know when I use the product rule? When I have a product of functions. When do I use a quotient rule? When I have a quotient of functions, a fraction, right? When do I use the chain rule? Always. I always use the chain rule. Okay, so first of all, what is the chain rule? If y equals f composed of g, right? So I have a composition of functions. Assuming the derivative of f exists and the derivative of g exists, we know that y prime is f prime of g times g prime. So I'm going to teach this to you a couple of ways. I'm going to talk about inside function, outside function, and I'm going to show you a loop. Okay? I find it easier to think about inside outside functions than I do do a loop, but I still like to show a loop in case that's the way you would like to think about it. So clearly this is my outside function, right? And this is the derivative of the outside. Notice that I'm composing with g of x, right? In both, right? So this is my inside function, and this is still the inside function, right? But then finally we have the product, right, of the derivative of the inside. So I like to think about, and this is a little bit weird, I like to think about y equals a box with a cat in it. Now, I'm a dog person, so don't try not to take this the wrong way. I'm going to push the box down the hill, okay? So what's happening to the box? It's moving, it's changing, right? And that's what a derivative is, right? How something is changing, yes? So now f prime is how the box is changing, but the cat's still inside of it. You see what I mean? So I'm finding out how the box is changing with the cat inside, and then think about, and I'm multiplying by how the cat is changing, right? Yes. So the cat, imagine the cat jumping around in the box, it's going to make it move down the hill differently than if the cat is just sitting still, right? So so I can see that this, right, this thing is changing, right? It's now how the box is changing with the cat inside, right? The cat's still inside, right? Times how the cat is changing. So the key is that you think about what's inside of the original box and you keep it in there, right? But it then could contribute to how the thing is changing itself, right? So there's that multiplied by the change of the inside function, right? So that's a little bit strange, but I'm trying just to give some insight into how I should think about this. okay? The proof is a little bit controversial in that there's arguments about that you have to include possible discontinuities, but if you go look for a proof of it, you'll hear about, you know, PhD students or even professors arguing one way has to be thought of or another. It's not that complicated. It's going to be with the definition of the derivative, right? So take a look at that if you want. I know there's a couple of you that might want to look at it. Let's do some problems to show that it's correct when we don't really need it, okay? So let's show some problems where we can show that it's correct when we don't really need it. And then we'll do some where we have to have it, okay? Again, our key is whenever we're doing a derivative, we're doing chain rule. In fact, we've already been doing it, right? So like y equals square root of x. We know the derivative of the outside function of the square root function is 1 over 2 square roots of x. And then the inside function is x. What's the derivative of x? It's 1. So we've been really doing that's y prime. We've been doing the chain rule all along. Only thing is the derivative of the inside function was always 1. So, but now it's not going to be, okay? Now it's not going to always be 1. So, for example, if y equals sine 2x, what's our chain rule say? Well, what's the outside function? The outside function right now is sine, right? And we know the derivative of sine is cos. And I'm going to keep the cat in the box. So what's staying inside?
2x.
2x. And what is the derivative of 2x?
2.
2. So there it is. 2 times cos of 2x. Now I said, so that's by the chain rule with the inside-outside function. Let me show the loop real quick, right? So what's my outside function? Is sine. What's the derivative? Cos. The inside function is 2x. What's the derivative? 2. And I'm going to use the letter C for chain rule to get my y prime, which is cos evaluated at 2x times 2. So cos, right, is going to be evaluated at the inside function, right? So this is my outside derivative here, right? This is my inside. This is my inside derivative. And the book notation is a little different, but that's fine for their process. But just thinking of the general outside function, just with whatever with x as the variable, get the derivative, get the inside function, get the derivative, and then think of that c. So derivative of the outside evaluated at the inside times the derivative of the inside. Now this one we know we could do without the chain rule, right? Even though we always use the chain rule. This is what? 2 sine x cos x, right? So my first function by a product rule is 2 sine x. What's the derivative of that? 2 cos x. The second function in the product is cos x. What's the derivative of that? Negative sine x. And then we're doing our product rule. So it looks like I get 2 cos squared x minus 2 sine squared x. So I could factor out the 2, and then I should recognize that derivative. I should recognize that identity. What's that identity? Nope. Cos squared plus sine squared is 1. It's cos 2x. So same answer, right? As my chain rule.
Can you just check it, like keep it there?
Yes. Stop moving around.
Will the chain rule always have the same answer as the product rule, or no?
Sometimes you won't be able to use the product rule, right? I can only use the product rule if there's a product. So, but I'll always use the chain rule. Always. Every single time for the rest of your mathematical careers. In fact, probably even all the time, forever, whenever you think about what you ate for lunch, which is inside of you, giving you energy so that you can do something, right? So how I'm changing with my lunch inside and how my lunch is changing, how my body is processing, right? So a reason to chain rule, a reason to eat healthy. Abraham, you there? Chris, you there?
I'm here. Yeah, I'm here.
Thank you. Let's do another one where we don't have to do a chain rule, right? But we will, just to make sure it works, right? We'll do a chain rule. We'll see that we don't have to do a chain rule, and then we see we get the same answer, okay? So let's do y equals e to the 2x is the easy one, right? So what's the outside function here? E to the x, right? So the overall outside function is, in general, an e to the x function. And we already know the derivative is an e to the x, right? So I'm going to get the derivative of the outside, which is e to the x, but keep the cat in the box, right? So keep the 2x in there. And then what's the derivative of 2x? 2, right? So y prime is 2 times e to the 2x by the chain rule. You can see my loop here. E to the x is the outside function, derivative is e to the x. But the inside function is 2x, and the derivative of that is 2. So I'm going to take the e to the x and put the 2x inside, right? E to the x evaluated at 2x times another 2, times the derivative of the inside. And it almost looks like a C. I'm trying to circle that 2x to show you that 2x is inside the derivative function, right?
Professor, when we take our first term, which is the the other term, we don't include the inside term with it?
Yeah, I want to think of it in general, and this is my process. But if you are already comfortable with the chain rule, you can do it any way you want, right? So, but I'm just trying to give a process to students who have never done it before or have had trouble with it before. Again, I like inside-outside function, right? But this is a possible way to do it, is this little loop I have.
But like in this case, like when people do the derivative of e to 2x multiplied by 2.
Yes. Yeah, I got it, right? E to the 2x multiplied by 2.
Oh.
All right, well, y equals e to the 2x is e to the x times e to the x. You agree? Because when I multiply like bases, I add the exponents. So x plus x is, right? So this is pretty simple one. I got a product rule now. First function is e to the x. Derivative is e to the x. Second function is e to the x. Derivative is e to the x. And I got a product loop, right? I get y prime is e to the x times e to the x plus e to the x times e to the x. So 2e to the 2x. All right, but let's look at one where we have to use the chain rule, right? Let's look at one where we have to use the chain rule. So like the one I was going to put on your test, right? So find y prime if y equals square root of 5 minus 2x, right? So my outside function is a square root function, yeah? So I know that the derivative of a square root function is 1 over 2 square roots, right? But I want to keep the cat in the box, right? So what was originally in the box is 5 minus 2x, right? But then I want the derivative of that. So I'm going to multiply that by the derivative of 5 minus 2x. So I'm using a little placeholder here. You can see I've got the derivative of a square root function evaluated at what was inside times the derivative of what was inside, right? So I give myself a little placeholder so I can think for a minute, and then I know I get what, negative 2 here is my derivative of the inside. So I get minus 1 over square roots of 5 minus 2x, right? So on your test, I'm going to tell you to find that derivative using a limit, and then you could possibly check with the chain rule. Now, where they start to get nasty, how we doing? We feeling okay about this? So, and if you're panicking about, you know, that we have a test coming up and he's teaching me new stuff, I understand. I do.
It seems like mostly the product rule, but you just have to follow slightly different rules.
Yeah, I mean, yeah. There's, right? This is definitely not a product, right? It's a composition.
Well, no, yeah. But the method is kind of similar, the way you're teaching at least.
Yep, exactly. I'm trying to be consistent how I show things. You know, but we're forever now going to be thinking about the inside function, outside function, right? So when it gets kind of crazy is when I start to do combinations of product rule and chain rule, or quotient rule and chain rule. Remember, you're always thinking of the chain rule, always, okay? But let's look at a typical problem that I like to give on every test. So if I look at the midterm, I'm just opening our Blackboard page real quick here. Give me 1 second. So I'm in past exams and etc. I'm looking at chapter 3 from fall 2019. And this is number 2. So this is fall 2019 test, chapter 3 test. Number 2. I've got f of x equals x squared minus x all cubed times 2x minus 1 all squared. So, product rule, right? Yes, everybody with me? Let me do an easier one first, okay? That will help with this one. Sorry. Let me come back to this one. But don't get rid of it because it's one of my favorite questions. It's always on every test. So it's on your midterm. I'm sorry, it's on your chapter 3 test. Can't see you all. There you are. Sorry. All right, so let me do an easier one first, okay? Sorry. Y equals sine squared of x. This one's, so I just wanted to go to one with an exponent first, and I'm going to ask you, what is my exterior function? What's my exterior function here? What's the process? What's the operation happening?
Sine squared.
Squaring, exactly. So I'm really thinking of x squared. And what's my derivative there? 2x. The inside function, so it's really nice to think of this as sine of x quantity squared, right? That's a nice way to think of this, right? So you can see that 2 coming down, right, as the exponent, yes? And now I'm 2 times sine, that's the cat, to the first power, times the derivative of sine. So the inside function is sine. What's the derivative of that? Cosine. So I'm taking the 2x, putting the sine inside, and then multiplying by cos, right? So I get y prime, is 2 times the sine of x, notice the cat in the box, times the cos of x, and that's sine 2x. Right, that's a trig identity, yes. How we doing there? We okay? Nice.
So that's 9x multiplied by 2x?
Where, the last answer?
No,
not multiplied by. Remember, this was my outside derivative, and I put the sign inside. I keep the cat in the box. Right? Put the cat back in the placeholder. Okay, we're ready for the next? Yes? Here we go. So I see a product rule, right? I see a product of two things. My first function is something cubed, right? My first function is something cubed. So what's my derivative going to be? 3 times that something squared, right? So 3 times the something squared, what it was in the box was an x squared minus x, but what's the derivative of that inside? It's 2x minus 1. Can you see that I took an x cubed function and the derivative became a 3x squared, right? But the inside is more complicated than that, right? So I keep the inside in there, but then I take the derivative of the inside. Is that okay with everybody? Nice. Second function is something squared, right? My second function is 2x minus 1 quantity squared. So the derivative is going to be 2 times the something to the first power, right? 2 times something to the first power times another 2, because the derivative of 2x minus 1 is 2. So I'm taking the derivative of the inside. I'm doing a product rule. So I'm going to get y prime. I'm going to do it, in this case, I'm going to do it in order. I've got 4 times 2x minus 1 times an x squared minus x quantity cubed, right? That was from here. Just trying to put my coefficients first, plus 3 times a 2x minus 1 times a 2x minus 1 squared times an x squared minus x quantity squared. And I'm trying to be careful here. I'm taking the 3. I'm taking the 2x minus 1 times another 2x minus 1 squared. And then finally, the x squared minus x squared, right? So I'm trying to be really, really organized here. What do I want to do? I want to factor. I want to factor, okay? Don't want to distribute. It's very rare that we're going to FOIL something out or distribute something else. Very rare. In fact, almost never. Unless I can't factor. If I can't factor and I have a sum or a difference, I want to distribute things out. But when I already see I have shared factors, I'm not going to do anything with it. So you can see from the first piece, I can certainly take out a 2x minus 1. Right? So the first factor I can take out is a 2x minus 1. The second factor I can take out is an x squared minus x quantity squared. And now the question is, what do I have left? Right? What do I have left? So it looks like I still have a 4 left, and I have an x squared minus x. From the second term, I have a 3 left, and I have a 2x minus 1 quantity squared. Is everybody with me? The calculus is done, by the way, right? Now we're doing algebra. But it's usually where the snag happens, especially if you have weaknesses, right? If you got holes, if you never did your factoring, right?
This is going to need practice.
Yep, it takes some practice, and there's lots of problems for you to practice, including in the book. So in this one, I have to distribute here, because I can't factor this piece right now as it is. So, but if I expand it out and combine like terms, I might be able to. So I've got 4x squared minus 4x plus 3 times 4x squared minus 4x plus 1. Right, I'm distributing there. Notice every time I write, I'm writing a complete sentence. Yes, I waste paper, but so what? I get the problem right. So you're really not copying me here, right? You're just racing me. And it turns out that this one does factor, right? 3 times 16 is what? 48. So I'll do a little side work here. So back to my factoring. And you think you might be done here, but there's another factor that can come out. What's my factor from here?
An x?
Almost.
X minus 1?
Yes. Almost, though.
X minus 2?
No. It turns out that there's an x squared that comes out of there. And then most likely we'll write it as x squared times 2x minus 1 times x minus 1 quantity squared times 4x minus 1 times 4x minus 3. There it is. Boom. Oh. Remember what I said. Chain rule's confusing. It gets tough here. I'm more concerned that you're ready for the test than you work on any chain rule piece. Okay? So if this is putting you into a panic, forget about it. Okay?
Professor.
Yes.
Sorry, you phrased my question. I'd say, would you recommend the most going back on Blackboard and looking at questions on previous tests and just do a whole bunch of those?
Yes, it should have been done. Should have been done already. Old tests should have been done already. Yes.
What should we use? To cheat to find the answer if we get stuck.
Hopefully something on your formula sheet. You can always ask me. I'm going to answer as if I would answer to everyone because everyone will hear me.
Okay.
Improvise.
I'm just saying for practice.
Well, you got all my answers.
Oh, okay. Then there's my answer.
Yeah. All my answers are there.
Okay.
I think there's one test in Chapter 2 that doesn't have a blank test. Right? So that
you just get the answers by default, yeah.
Well, yeah, but you could be on the honor system and just look at the question on the closed.
If you're practicing, you're just taking the honor system regardless. So
right. That weird factoring I did there was from there. Well, I don't want to do too much. We talked about the chain rule in general. We did a couple of little simple tricky problem. One simple little tricky problem with that sine squared. And then we did, like one of my favorite problems to put on the test. And I don't think we need to do anything else. So we're going to meet Wednesday. We're going to review. Right, get me some problems. And then Friday's the test. Pretty exciting.